Alright, welcome to the podcast for Chapter 1, Section 3, Direction Fields. How to solve a differential equation without doing any math. Alright, so what is a direction field? It is a graphical solution to a first-order differential equation. So the big question is, when you take a derivative of a function, what information does it provide about the function? So the information that it gives us is information about the slope of the function. Since we know the function of the slope for our differential equation, we can plot the slope of the function for every point in the region we're interested in. So, and we call these plots direction fields. So, what do we do? Well, let's take this differential equation here. And you see this differential equation here. This is right here the function of the slope. Y minus x tells us how the slope of our solution changes at every x and y point. So if we do that, and we can create a grid of points for all these x and y points. In this case, I've just chosen 4 points, and we get these values for our slope. And now at each of these points, so at minus 1, x of minus 1, 1, I can draw in the slope of the function, which is 2. And at 0, 1. So what would that look like? Well, it looks kind of like this. So let's look at this point. We have x of a minus 1 right here, and y of a 1 is right there. So our slope there is 2, and you can see it. That's what these little arrows represent, the slope. And then from that slope, you can see how the function should be changing based on the slope. So here, it looks like the slope is pretty constant. Here, it looks like it's leveling off, 0, slope of 0. Here, it's negative. All this region is negative. And so this information gives us a lot about the solution of the function. So how can we get a solution? Well, that depends. So here's our solution. It depends on our initial condition. And so I want to choose this initial condition, x of minus 1, y of 1. And so how do you get a solution? Well, that's the slope. And if we were going to create another function, our curve has to be tangent to our slope. So we could start off this way and go this way and then come back this way. And so if I plot that line, we get a line that kind of looks like this. And that's a solution curve, at least on the region that I've plotted. So x goes from minus 2 to 2 here, and y goes from minus 2 to 2. And so for this particular region, I've got this solution for this initial condition. And I can pick any initial condition I want, and I should be able to generate this solution curve that is called this gold line here. That is the solution curve. Alright, so how do we create these to help you solve first-order differential equations? Well, the old school way is you get out a paper and pencil, and then you calculate the slope for every point in the interval we're interested in. Now, that's very tedious, and I don't recommend anybody doing that because it's very tedious and time-consuming. Or we can use computer software. Since today's computers are very capable of doing this, we're going to use that. The program we're going to use is Maple, and Maple is in the computer labs. You should be able to access in the computer labs, or you can download a student version for I think about $75. I can get you a code to get you a 25% discount off the normal $99 for the student's version, and I'll give that to you in class. Alright, so how are we going to, what is Maple? It's some software. We're going to show you more how it looks in class, but to get a direction field, the easiest way is you go to the Tools feature on the toolbar, click Tools, and then click Math Apps. After you click Math Apps, what you're going to see is this search window. So what you want to do in that search window is you come down here to page types and you select math apps and page types, and then you're going to do a search for direction. That's all you should need is direction. And then once that pops up, you see here math app direction fields. You want to click on that, and that should execute the direction fields application. And if you scroll down a little, you'll see this type of window. Above it, there's a description on direction fields and how they can be created. And then down here, you'll get this app that you can do. You can either use this drop-down menu to select a function that's already there, or you can create your own. You enter the function, you can zoom in and zoom out, and if you scroll down a little more, you can pick an initial condition which will plot the solution for that initial condition. So that's the first way of doing it. The second way you can have is what I call, if that doesn't work for you, you can do the you can type in command lines in the Maple worksheet. So you create Maple, it should automatically open a worksheet for you, a blank worksheet, and the first line you should type in is with DE tools, just like this. That what's that going to do for us? Well, it's going to load the DE tool package, and inside the DE tool package is this command we're going to use called DE plot, and that allows us to plot direction fields for differential equations. So the next thing is you got to type it out just like I've got it right here, DE plot parenthesis, and then you got to plug in the differential equation you want to solve. Now when you do the differential equation, it's important that you distinguish the dependent variable y with the independent variable x, and it's important that you show that y is dependent on x. So every time a y shows up, you need to put y parenthesis x, and so we're going to solve this differential equation right here. After that, you need a comma, and then you put in the function that you're trying to solve for, because we want to find y of x. And then comes the ranges. You can put in your range of your interval you want for x. You can put in the range of the interval you want for y. And basically you start the lower bound, dot, dot, upper bound, lower bound, dot, dot, upper bound. A comma's in between. And then the last thing is the solutions you want to plot. So you have to put in your initial condition right here. So I have a pair of initial conditions here. If you would just want one, you would eliminate this part right here and the comma, and you'd still need the second square bracket. So this is one initial condition, x, y point, x, y point, and so yeah, I have two initial conditions that we plot. And so when you create that curve, what's the graph you're going to produce? It should look something like this. So this is plotting the first one, and that's the one you saw earlier, and then this is plotting the second one. So my second initial conditions is x is 3, which is out here, out of our region, and y is -1. So it has gone and plotted that solution that shows up in our region, and this would be this one. So you can choose any point inside our region or outside our region. It's just hard to see how it's going to go through that point out here, so I have to expand my limits. And that's basically how you can solve a differential equation without doing any calculus, just doing graphical methods. I'll see you in class on Tuesday.